Namaste. Welcome to tutorial series on process or bioprocess simulation using SuperPro Designer. In this tutorial series, I'll try to solve some of the case studies taken from the published literature, that is research papers or book chapters, to make you more familiar with the SuperPro Designer software. As we know, process simulation plays a very important role in development of industrial processes, that may be biotechnological process, pharmaceutical, food, and many more. And we have variety of softwares which are implemented in process simulation. Among them, SuperPro Designer is one such powerful tool which helps us to simulate both batch as well as continuous process. Even you can simulate semi-continuous or fed batch process using SuperPro Designer. And those who are beginners, I request all of you to go through the basic course which is developed for beginners to use this particular SuperPro Designer, and the link for the same is given in the description box. So if you don't have a copy of the software, you can go to this Intelligen website and you can download the trial version and you can install. The limitation of this trial version is you can add only 2 unit operation to the flow sheet. If you want to simulate a bigger process, definitely you need to buy the license. So in this tutorial, let us solve the problem, one case study which I have taken from the book Chemical Engineering Process Simulation, published in 2023 by Elsevier, and chapter 10 which explains the basic batch process simulation using SuperPro Designer. And also you can notice at the bottom it is given here, simulation and other electronic files of these chapters are made available on the companion website. So if you click this link, it will take you redirect you to this particular page, and you can download the supplementary files or software files which are given along with this particular book. So we are basically interested in chapter 10 and 11 because these two chapters are developed based on SuperPro Designer software. The case study which I have taken in this particular tutorial is based on the publication, that is modeling and optimization of Eurycoma longifolia water extract production. So I request all of you to go through this particular paper for better understanding. A simple version of that particular example is explained here, that is case study on biochemical production. So I request all of you to have this copy before viewing this video. Let us solve this problem using SuperPro Designer. For your kind information, I am using version 13, that is trial version, build 2 of SuperPro Designer, and also the mode of operation chosen is batch mode. So this is basically a batch process. The mode of operation is batch mode. So in SuperPro Designer, when you solve any problem, so we need to understand what is the basic information of this particular case, and also we need to initiate the process by registering the pure components which are required, and also we need to develop the process flow sheet, and we need to initiate the stream operations, and we can simulate, and later we can schedule, and also we can perform the debottlenecking analysis. So let us go step by step. In the first step, so we need to register pure components required for the simulation. So if you could able to go through this particular problem statement, we can understand that 3 pure components are required for the simulation, that is water. Basically they are extracting active ingredients from the Eurycoma plant. So that is basically a hub. So we need hub, and we perform an extraction at that particular temperature and using water as a solvent, and we are going to get a product as active ingredients. Means whatever the contents are going to leach into the water, that is nothing but an active ingredient that is of our interest. So we need to register basically 3 to 4 components will go one by one and we register them. First we should go to task, register pure components, and in this literature, if you could notice that table number 10.1 which shows that the components required for the simulation, that is basically water, and we know water is already available as a default component in SuperPro Designer. The next one is we need to register the herb and active ingredient. Herb is not available in the SuperPro database, so we need to register it as a new component. So I'll register as a herb. So I'll just go with all the default names or keys, but this one herb is basically a biomass. Whatever the plant is basically a biomass. So instead of registering with water properties, they have registered as biomass. So we'll register as a biomass component. So click OK. And also the extract what you are going to get, that is basically the compounds which leached into the water. So that is I am registering it as active active ingredients, and I can name it as local name as act ingredients. So short name I have given. This one we will register with water properties because they are water soluble components, and there are multiple components in the plant extract. We cannot define all the components available in the herb, so we are just registering it as an active ingredients, and we are registering with default properties of water. And also once you extract that particular herb, when you put it in water, when you extract it, we are going to get two components. One is extract and other one is waste component, because post extraction whatever you are going to get, that is a waste component. So again we need to register that waste component also. So we will register as waste. This also once you just get extracted, because extract may be 1 or 2% in the particular plant, so rest all again becomes biomass. So we will register with biomass properties. Click OK. So what are the 4 components required for the simulation is registered with the default properties of water and biomass. And the next step is we need to develop the process flow sheet. So to perform this operation, if you read the problem statement, first they have extracted and later the extract is concentrated using spray dryer. So we need a reactor to perform an extraction. And next one, we need one more equipment, that is nothing but a spray dryer. You can go to drying and you can select spray dryer. So these are the two two procedures or equipments which required for this particular simulation. So now let us see step by step how to initiate this particular stream as well as operation. For convenience, I will simulate one procedure at a time. So I will delete this particular spray dryer. Once we initiate the stream and operations for this particular reactor and simulate it, if we don't find any errors, then we go to the next step. It is the best way of doing simulation. Many people try to do like develop the complete process and initiate and try to simulate it. But if you get errors in or multiple errors in the simulation, it is very difficult to rectify and correct it. That is the reason it is better to simulate each procedure one by one. In the first step, let us start simulating it, and once you read the problem statement, so we can understand that we need to charge two things. One is we need to charge the herb, and one more thing, we need to charge the water, because that is the solvent which is used in this simulation. We will rename this particular stream. We'll rename this stream as herb and water. Okay, so once the extraction is done, so what happens, we are going to get the extract, and also we are going to get the waste, that is whatever the post extraction we generate the waste, we are going to get waste as well as extract as output stream. And also if you want to make it as an open vessel, you don't want it to be a pressurized vessel, you can also connect it to a vent stream. You can rename this particular output stream also. So I'll rename it as a vent, and this one could be renamed as waste, and this we will rename it as active ingredients, or we can also name it as extract for the convenience. Okay, so we added all the streams which is required to this particular reactor. Next, let us initiate this particular stream, and we can notice one more thing here. Each equipment is given or named with something called as procedure tag P1. Once you add the next procedure, you are going to get P2. Whatever procedure it may be, let it be reactor, let it be filter. For example, I will take this particular dryer and tray dryer and I will place it here. You can notice that it is a procedure 2. Irrespective of what type of procedure is, so how many procedures are in this particular process is given by this P1, P2, P3, P4, so like that. And this R, whatever the symbol R you notice, it is for that particular type of category of that particular procedure. For example, in this case, it is reactor. If I go to batch vessel and if I select bioreactor, you can notice something called as BR, that is bioreactor. So if you have a fermenter, you get FR. So like that, each equipment has given particular code or particular tag is given, or equipment ID is given, and you can notice that 101. For example, you have multiple reactors, you are going to get 102, 103. Why this 101, 103, 2 is important? Many times what happen we do is some equipments are used at multiple times. For example, initially if I use something to prepare a media, and once the fermentation is started, that particular equipment is idle. Later, if I want to store the fermentation broth before going for any of this downstream process, I can reuse the same equipment. So if you want to reuse, I can have the code and I can choose it. So let us see when we perform the advanced simulations or like a bigger process simulation during debottlenecking analysis, or like make it more economical, how to kind of reuse some of this idle equipment. We'll see them later. So I request all of you to go through this problem thoroughly so that you can understand better. And as we know, this is a batch process, so we need to add the operation. In the SuperPro Designer, continuous operations, we no need to add the operations. By default, operations are available. In some equipments, there are options to add some more operations such as CIP, SIP and all. But in the batch operations, we have to initiate, we have to add the operations and we have to initiate the operation. So in this particular process, a series of operations are required. If you could know, go through the table 10.2, they have given what are all the like operations involved in this particular process. So they are added in a sequence. You should not add them in haphazard manner. We need to add them in a sequence or in an order. First, we need to charge the water. Basically, we need to charge the water, or we need to charge the herb. And next, we need to charge the one more charge is required for water. And next one, once you are charged, it is the whole mixture need to be heated to reach the 95 degrees centigrade. That is the temperature at which the extraction is taking place. Once the mixture is heated to 95 degrees centigrade, we need to extract it. For a purpose of extraction, like here, the react operation is used to represent how the extraction is going on, to represent the mechanism of extraction, that is from the herb, the active ingredients are leached into the water and waste is separated. To notify that, here the react and the batch stoichiometric, not kinetic, batch stoichiometric is used, and once the reaction operation is completed for a particular time, then we need to split the components. We can use this split the components. This operation helps us to split the particular waste as well as the extract. And once the split operation is completed, we need to transfer out the component present in the reactor to the next unit procedure, that is spray dryer. I hope you understood. You can go through the table 10.2. It clearly shows the series of operations or sequence of operation employed in this particular procedure, and also they have given the operating conditions. So we'll see them later. So click OK. And next one, let us initiate this particular stream, the herb stream. And in the problem statement, it says that, so they have used the solid to liquid ratio, that is herb to water ratio as 1:6. So that here they have charged almost they have charged 40 kgs of herb, 40 kgs of herb. It is 100%. That's the reason I have said 100%. There is no other component in this particular stream, the 40 kg, and rest all are going with the default properties, that is temperature 25, pressure 1.013 bars. Rest all are same. So click OK. And also we can initiate this water stream also. We will initiate in different way. So I'll go to the operation. Next one, let us initiate the operation. We go to operation, charge. So in this particular first charge, we will charge the hub. We'll charge the hub. How much we need to charge? We don't need to initiate anything here because we are already initiated the stream. So we'll just click on the stream. You can notice that hub is 40 kg is added, and all the rest, all the setup time and process time, we go with the default values available in the software. The next charge to the reactor is water. But if you could notice, when I click on use amount on stream, you get 0 because we have not initiated that particular stream. So do we need to cancel and go back there? No. You can just click here. You can click here and you can initiate it. So I need to select the water. So as already told, water is a liquid, so we need to select the volumetric flow rate. So as already mentioned, the solid to liquid ratio is maintained 1:6. So it means that 40 kg of herb we have loaded. It means that 240 liters of solvent, that is basically water, need to be filled. So that is 240 liters per batch. So once you notice, it is appearing here. Click OK. So now this is you can see it is reflecting here. So click next. So even in the manuscript, they have nicely given the images, so they are very clear and you can easily understand how to initiate this particular the stream. That is, one is herb stream as well as water stream. Next one, so in the problem statement it says that we need to heat the mixture to 95 degree centigrade. So already unit is degree centigrade, so I'll just type 95, and steam is used as heating agent, and rest all we go with default values. And one more thing, they says that heating need to be done for 30 minutes. I'll just change it to 30 minutes. Rest all we go with default properties, and we click next to take us to the next operation, that is a react operation. In this you can notice that we need to set the parameters. This reaction, or basically it is not a reaction, it's an extraction process, but we are defining how basic extraction is happening. So the extraction process is happening at 95 degree centigrade, and heat transfer agent, the chilled water is chosen. You can choose steam as an heating agent because we need to maintain that particular 95 degree centigrade throughout the process. So we keep it as steam as a heating agent, and also the setup time we will retain it as 0, but process time, that what you call basically reaction or extraction, is for 2 hours. I have selected hour first and I have selected 2 hours, and rest all we go with the default values. And one more important thing is we need to set the reaction, how basically the extraction happening, we need to set it. So we go to this conical flask symbol, select this conical flask symbol and select the reactants and product, that is herb is getting converted in the sense leaching from the herb. These active ingredients are getting leached, so we are going to get active ingredients and waste. Water is not involved, or water is not a reactant, it's a solvent. Okay, and here there is no reaction is happening, it's a physical process and there is no reaction is happening. So herb, when you extract it, you are going to get active ingredients and waste is generated. And also basically the stoichiometric equation is given based on mass, that is one herb, or basically like 1 kg of herb or 1 gram of different mass units, it gives around 0.03 active ingredients and rest is waste, that is 0.97. You can notice here both the side it is balanced. Click OK. And the conversion, they assumed it as 100% conversion, and the rest all we go with the default values, and we go to the next operation. So the next operation is the split operation. Here we assume that the split and whatever is coming out of this particular outlet port, you can choose here as a waste port, means whatever the solid contents are there that which are coming out are from the waste stream, and what need to be split from this particular waste is like 100% active ingredients. We need to split 100% active ingredients, and also we want to select 100% water. Sorry, this is waste and 100% water. These are the 4 components which are coming out, split out from this particular waste stream, and rest all we go with the default values. And also he says that split operation is for 10 minutes. Split operation is for 10 minutes. Rest all we go with the default values. We go to the next operation, that is transfer out. Again, in this transfer out, the output stream is this extract stream, and rest all 100% we are transferring out the contents from the reactor to spray dryer. So that's it. Click OK. So we have initiated the stream, we have initiated the operations. Let us solve this particular process. So that is solve the material and energy balances. Click. You can notice that the perform M and E balances ended successfully. Fortunately, there are no errors. So let us see what is present in this extract one. You can notice in the extract there is 1.2 kg of active ingredients are there, and water is something around 238.72. Basically, if you take it in liters, it is 240. It has not consumed in the process, so whatever you have fed the water, it is coming out. So totally you have got 1.2 kg of active ingredients. And also, if you could notice the waste stream, which contains 38 kg of particular waste from the herb which is derived. And if you could able to notice the vent port, so nothing is available. So you can also, if you want, if you just select the equipment data, you can notice so how much reactor volume is required. That is something around 316.2 liter of reactor volume is required to carry out this particular process. And also, if you could notice equipment contents, and during the process P1 solve material balance, and you can notice there is a pressure change. For example, you can notice 1.013, later you can notice there is something around 5.76. If you want to make it open vessel, so you can go to this particular vent operation. Each operations you can go and you can select the vent and you can choose the venting. So already we have connected to vent. You can notice the vent port is available. You can make it open vessel, or else if you want to set that particular pressure you need to maintain that particular pressure. So once you make it open vessel, it becomes the vessel maintained at atmospheric pressure. So you want to maintain some particular pressure. I want to maintain 2 bar, 3 bar. So then this particular software will take care that if it is pressure is increased, so that the pressure release will happen and it maintains the required pressure. So in this case, I want atmospheric pressure. I'll just select venting and open vessel, and you can see this, you can click this, it will take you to the same tab in the next operation. You can notice here also venting. You can select vent, open vessel, select venting, open vessel, click next, venting, open vessel, click next, venting, open vessel, and next operation is split transfer out operation, again venting, and click open vessel. So click OK, solve material balance, and if you could notice here during procedure P1, you can notice now it has become open vessel. The whole throughout the process the pressure is 1.013 bars. Okay, so this is how we need to initiate the reactor. The next very important thing is we need to perform the spray drying process to concentrate or to get the extract the powder, active ingredients powder. So for that I will just delete this particular extract stream. I will add another unit procedure, that is drying equipment, and I'll select the spray dryer, and we connect it. If you could able to see this port, this is the feed where we need to feed the dilute extract in this one, and this is the product which you are going to get. This particular stream is the product which you are going to get. If you have any doubts about this input and output ports, just click and right click, and if you click on this L, so it will redirect you to the page where it will clearly explains you what is this input and output ports. And also there are ports for connecting the gas, because basically spray dryer is you are continuously supplying the hot air so that it instantly dry. and the moisture or water is taken away by this hot water, and you are left out with active ingredients powder. So here it is primary gas. If you want to have one more gas inlet, you can have a secondary gas. So I'll just first connect this particular extract stream into this feed stream, and we can connect the hot air to this particular primary gas in, and we have a active ingredients powder, and also we are going to get the air from this particular spray dryer. So this is the streams required. These are the streams required for the spray dryer. We'll rename them. So again, I will just rename it as extract, and this is hot air, hot air, hot air in, and this is hot air out. Okay, this is the active ingredients. So we have renamed all the streams. So let us see how to initiate this particular process. So first we need to initiate this hot air, because air is one more ingredient. Basically air is available as stock mixture by default in the SuperPro Designer. So to understand better, you can go back to the tutorial series which is developed to teach the basic aspects, where I have taught how to register stock mixture. So in this case, to register stock mixture, so air is already available as a stock mixture, we no need to register again. So we will select air as a component, click OK, and you can notice one thing. We don't know how much air is required to dry this particular extract to perform the spray drying process. So that is the reason it is selected auto adjust. Means software will automatically calculate the quantity of air required to carry out this particular process. And also we can notice the initial value will be 100 kg. Once the material balance is solved, automatically this value will change. We'll see to it later. And also the hot air, basically we need to send the hot air to this particular spray dryer. So the hot air, the temperature is 170 degree centigrade. They are expecting the hot air which is sent into the spray dryer is 170 degree centigrade, and rest all we go with the default values and click OK. So we have initiated this particular stream, means we need basically we charged the air. We cannot charge at a time one time, it is continuously supplied. So, and we no need to initiate this particular extract stream, because the output of this vessel is input to this particular spray dryer. Now we need to initiate the operations. So when you right click, you can notice that it is basically a continuous operation, and further you have an option to add the other operations like CIP, hold, SIP. So in this case study, they have used the CIP as one more operation. So means once the drying is done, they are carrying out CIP, that is they are cleaning the spray dryer. They have used one more operation. So I am just adding one more operation here. Click OK. Let us initiate one by one the operation. First we go to dry operation. Dry operation. You can notice here the operating conditions, like whatever we need to dry, the operating conditions. So the rest all with the default values, and we need to understand how long we need to carry out the process. Here they says that they are carrying out the process for 22 hours. They are drying it for 22 hours. And also the feed rate and all these things, we go with the operation rate is 100 kg per hour per meter cube. We will go with the default values, and setup time is maintained for 15 minutes to initiate the process or cleaning or whatever the preparation of the process. And here very important thing is main drying. So here what need to be separated, so especially the loss on drying. So what is available in the output, the gas stream. So we can assume that active ingredient, that is 1% active ingredient is lost. Basically 1% set by you. You need to select set by user, that is 1% active ingredient is lost, and we assume that 100% water is taken away. So 100% water is taken away or dried or removed. So you can also set the loss on drying. All these things are by default. So it is chosen 5% loss on drying, after evaporation is 5%. Rest all we go with the default values. I hope you understood. We set losses. Basically, this is a losses, active ingredients 1% loss. We cannot have something like 100% you are going to get active ingredient. Definitely there might be losses will be there. These active ingredients may be volatile constituents. They might escape with this particular hot air. So we are just assuming 1% loss of active ingredients, and we need to remove 100% water. And the next operation is CIP, that is clean in place. You can notice clean in place, pure components we are just washing with water. Rest all we go with the default values. Will not worry much about this. Click OK. So now we initiated the two operation in spray dryer. One is the dry operation, which was available default in this when you choose an equipment, and we additionally added one more operation called as clean in place, and we initiated that. Let us solve the material balance, and it is showing some error. The specified product temperature of drying is 70 degrees centigrade must be greater than the feed temperature. So we need to set somewhere we have missed out. So we will just go back to this operation, that is dry operation, and there is one more thing is mentioned, that is gas outlet temperature. Yes, we need to set the gas outlet temperature, that is primary gas outlet temperature. Our product temperature is 98. We select the product temperature as 98 and click OK, and we try to solve. Yes, again it is showing error. The specified primary output temperature is output gas temperature is 150. Gas temperature, output gas temperature is 150 and product temperature is 98. Click OK and solve the material balance. Yes, we could able to rectify. This is hard. What we are supposed to do when we get an error, it clearly shows what is that error. We can go back to those particular errors and we can rectify them. In this case, I missed out choosing what should be the outlet gas temperature, as well as you can notice here primary gas out temperature as well as product temperature I missed out. I actually set it to 75 degrees centigrade, but calculation software what it calculates, it shows that the temperature is lower. What is the calculated temperature is lower, it is not feasible. So we can set the particular temperature. Click OK, and we can notice now what is the amount of active ingredients you got. So there is something around 1.18 kg of active ingredients are produced from this particular process. And if you could notice this hot air, and you can notice there is something around 0.012 kg of active ingredients are lost in this particular process, and water, again complete water is recovered. So this is basically a simulation of this extraction process. So I hope you understood how to initiate, how to register pure components and develop the process flow sheet, initiate the streams, initiate the operation, and also we found some errors in the simulation. I also showed how to rectify them, the errors, or how to correct them, and finally we could able to solve this, and we got the results. In the next video, where we will I will teach you about scheduling this particular process as well as to perform the debottlenecking analysis. So thank you for your patience.